Welcome! This video is going to explore how we can go through a list and find the smallest value. So say I have in BYOB a list of scores, 16, 12, 18, 11, and 19, and I want to find the smallest one. Now we can just scan that and see, oh, it looks like 11 is the smallest one, but that's not sufficient to be called an algorithm, right? That list of instructions, well, look at the list and see that that's the smallest one, isn't going to cut it for instructing a computer how to do this job. So we need a more formal description of this algorithm. Here's one possible version. So I'm going to make a block, and we're going to walk through this kind of by hand first, but eventually my goal is to make a block called find smallest in list. And the way I'm going to do it is to store the location of the smallest thing that I've ever seen. All right, so we're going to start by assuming the first thing I've ever seen is the smallest thing in the whole list. And then we're going to go through each item in the list, and so this is our basic recipe of we need an index, a counter variable that will start at 1. We're going to repeat as many times as there are things in the list. As we do the repeat, each time we finish doing the logic inside, we're going to change the index by 1 to go to the next thing. And our logic is going to be if the current item index of list, that's kind of, we should mentally translate that as the current item, is smaller than item location of smallest of list. So we should translate this as the smallest thing we've ever seen in the list. So if the current thing is smaller than the smallest thing we've ever seen, well, then we've got a new smallest one. We have to update what we've stored as the location where we can find the smallest item. And its new value should be the current location, the current index. So we'll go through that a bunch of times, and then we'll report back, oh, this is the location I think I found where we found the smallest thing. So let's walk through this by hand. We start, location of smallest gets set to 1. So this is basically making a new variable, location of smallest. We're setting it to 1 to indicate that as far as we know, the first thing in the list is the smallest thing there. And this is obviously wrong, but we'll have to learn that as we go. Okay, now we set up our counter variable, so index gets set to 1. All right, so that basically means we're going to have a new variable, index. We set it to 1, and now we're going to think of this as we're looking at item 1 in the list. And as we update index, that'll mean we're looking at item 2, 3, 4, etc. All right, so we're going to repeat a bunch of times. In this case, we've got 5 items in the list, so we're going to repeat this stuff 5 times. If item index of list is less than item location of smallest of list, well, let's go check that. Is item number index, so item 1 of list, 16, is that smaller than item at location of smallest, which is also 1, or 16? Is 16 less than 16? No, it's not, so we don't have to update our smallest. We already know that that's the smallest one. So we'll change index by 1. All right, so index becomes 2, and basically that indicates, okay, we're ready to go look at the second thing. Now, we're doing a repeat, so we'll come back up and start the second time through. If item index, so now it says item 2 because that's what we updated the index to. So if item 2 of list is smaller than item location of smallest, well, that's still 1 of list. All right, is item 2, the 12, smaller than item 1? Why, yes, it is. So that means we have to update our location of smallest to match the index. We found a new smallest thing. So we change location of smallest to be 2, and that indicates, oh, this is the spot where we found the smallest value. All right, so now we've got to change the index by 1 again. So now index will be 3, and it basically means we're ready to look at the third item. We'll come back up and we'll start the repeat process again because we've only done 2 times out of 5. So if item index, well, we just made index 3. So if item 3 is smaller than item 2, well, 18 is not smaller than 12. Okay, so we don't have to update anything. Well, then we change the index by 1. So we change the index to be 4. We're ready to go look at 11. Okay, so what do? We come back in to the repeat. Is the current item, item number 4, smaller than the smallest thing we've ever seen? Well, the smallest one we've seen is number 2, which was 12. Number 4, 11, is smaller than 12. So that means we've got a new smallest thing. And so yes, we've got to update the location of smallest. It was 2. We're going to change it to be where we are now, the 4. All right, we'll copy index to location of smallest so we know that our smallest value we've ever seen is at location 4. Okay, so we change the index by 1 again. That become 5, means we're pointing at the last item. We go back up, we check if item 5 of the list is less than the smallest thing we've ever seen, which is currently 4. So is 19 less than 11? No, it's not. So we don't have to do anything there. We'll change the index. So the index will become 6, which looks like a bit of a problem because now it's pointing off the list. There is no item 6. But the good news is we're actually done at this point with what we need to do. We were supposed to repeat it 5 times, and we've done that. So at this point, we're going to bail out of the repeat, and we just get to the last instruction, which is report location of smallest. Well, the value that's there is 4. So our block would at this point report back that the answer is 4. That's where you can find the smallest value in this list. All right, so with that kind of in mind, we're going to go build this block. So I've got a scores list set up and something to reset the scores if I need to, if I somehow mess them up. So I'm going to make a block and so I'm going to call it find location of smallest in, and I'm going to make this a reporter because I want it to give me back a number where it finds it, and it'll be a list block, and it needs to take in which list it's going to work on. Oops, and so let's call that list, and I'm going to go ahead and mark it that it can only use a list. All right, so I'm going to be testing this using scores, but I want this to be generic, so anywhere I'm talking about the list I'm working on, I'm going to use the term list. So let's go start translating the pseudocode that we've got into blocks. Location of smallest is 1. Well, this is trying to make a variable, and we could do that as a normal kind of global variable, but I'm going to go ahead and make this a script variable just to kind of keep things isolated to this block. So we'll grab a script variable, and I'm going to call this location of smallest, and I'll hit OK. Now the pseudocode says that I'm supposed to set it to 1, so I'm going to set location of smallest to be 1. All right, so that assumes that the first thing in the list is going to be the smallest. Okay, next up, we need an index. So I'm going to come back and we'll set something called index. Have another script variable, and it needs to be set to 1 also. And then we need our repeat. That's our basic recipe for going through the list. We're going to repeat. How many times are we going to repeat? Well, we're going to repeat however many times there are things in the list. So the length of whatever list we're working with. And what do we want to do? Well, we want to compare the current thing to the smallest thing. So I'm going to start with, I know as I go through the list, I'm going to have to update my index to kind of go to the next thing. So change index by 1. I know that needs to happen. And what I want to do is just verify that I'm kind of got the recipe right. So I'm going to say the current item. So item, how do I say the current thing? Well, I've got to say the item index of, I don't want to say scores, I want to say of my list for 2 seconds. So this will be the thing we're on. And I'm going to duplicate that. And so I'm going to say the current thing, and then I'm going to say the smallest thing. So item, not at index, but item location of smallest, which since we're never changing the location of the smallest, that should always be 1. So what I expect to see here is it to go through my list and say I'm on 16 and 16 is the smallest. And then go to 12 and say that 16 is still the smallest and work its way through like that. So let's try this out. So he's on 16, 16's the smallest. He's on 12, 16's the smallest. He's on 18, 16's the smallest. Okay, so I'm going to go ahead and stop him. It appears to be working. Now what I really want to do is compare those two things. All right. So I'm going to break out the hellos. I don't really need to be doing those. What I want to do is have a decision. If, and I want to compare these two things, if the current thing, item index of list, is smaller than the smallest thing, which I'll say as item location of smallest of list, then this is the new smallest thing I've ever seen, and so I'm just going to have him say found a small number, and just try this out before I worry about getting too fancy. And I'll have him say found a small number, and then I'll have him say the index where he currently is. So he's going to start out and he's going to assume 16 is the smallest one. And what I expect to happen is every time we see something smaller than 16, he should announce that index, that number. So when he sees the 12, he should announce, oh, I found a small thing at 2. And I'll check 18, and that's not small. And then he gets to here and realizes 11 is small. So he found a small one at location 4. All right. When we're talking about the index, we're talking about the location. If I get rid of index and I have him say this, say item index of list, right now he's going to actually announce the values he finds. Oh, he found a small number. That was 12. And then he finds a small number. That is 11. All right, so when I want to talk about the item in the list, I've got to use this. If I just want to talk about which number, 1, 2, 3, 4, then I'm just using index or location of smallest. So what I really want to do, according to my pseudocode, is change location of smallest to match the index. Right? Copy index into location of smallest. So the way I write that is with a set. I will set my variable, and I'm going to set location of smallest to equal, well, I want it to equal the index. And I'm going to go ahead and have him still say that he found a small number, but I know he's also changing this location of smallest, and so when he's done, we'll report out the location that he found. So the last step is we get done with a repeat, and we're going to have him report his answer. So report, and the final answer is the location that we think has the smallest item. Alright, so let's try this one more time. Find location of smallest in. Go ahead and start it up. So he finds 12 and thinks, oh, that's the smallest one now. He gets to 11, thinks that's the smallest one. And then we report the final value back at the end. All right. Let's get rid of the says and try this without the say. So we just want, what I really want to know is 4. That's the smallest one. All right, and we can test this by what happens if we make number 1 be the smallest. Good, it figures out that that's where it was. If I make number 2 be just plain old 2, it tells me that's the location of the smallest. So it appears to be working well. If I really want to make sure, I should probably make another list, other list, and add some values to it. So let's go add, and in this block, there's nothing in this block that prevents it from working with, say, letters. So let's make a list that's got some letters in it. And G, T, E, and A. So if I say find location of smallest in other list, he says 4, because A is the smallest letter. If I change that to Z, now that's pretty big, so E should be the smallest one. We should get 3. All right, this basic recipe I've got for how do I find the smallest thing, nothing in here depends on the fact that I'm looking at numbers. As long as we can say one thing in the list is smaller than another thing in the list, this will work. So we could use it for letters like I've got. You could put whole words there. Anything that we can compare using less than.